Good evening, everyone. Today we will be in section 5 of chapter 4. What we will be looking at today is how to show triangles are congruent by using two new postulates and theorems, angle side angle and angle angle side. So we looked at the case when we have three sides being congruent. We looked at the case where we have two sides being congruent and an angle. And now we're going to be looking at the case where we have two angles and a side being congruent. This will pretty much cover every single type of every single way we could show triangles are congruent. Will be wrapped up in this part here. So if I look, concept 15, triangles that have angle side angle matchup are congruent. So if I have it go angle side angle, the triangles are congruent. If two angles and the included side, so just like before, included side is the side between the two angles. So segment AB here is the included side because it's between angle A and angle B. Similarly, segment DE here is the included side because it's between angle D and angle E. So anyway, back to reading this. If two angles in the included side of one triangle are congruent to two angles in the included side of the second triangle, then the two triangles have to be congruent. That's just the way it has to be. If I have angle side angle, triangles are congruent. Angle side angle congruence, I believe it's postulate. So the included side, because it's between the two congruent angles, I have segment AB being congruent to segment DE, angle B being congruent to angle E, and angle A being congruent to angle D. So that would cause triangle BAC to be congruent to triangle EDF by angle side angle congruence postulate. I have those three things match up. That's the only single triangle I can make here, and this is our second to last shortcut that we can do. Similarly, triangles that have angle angle side, or if you flip it around, side side angle, it doesn't matter how you write it, it's still two angles on a side. If I have those match up, they are congruent. And this one ends up being a theorem. I could prove this using the last concept quite easily using the third angle theorem. Real quickly, if I have angle A and angle D being congruent, angle B and angle E being congruent, angle C and angle F have to be congruent. So I could have also done this angle side angle, angle side angle. And that's why angle angle side ends up being a theorem, is because it's a real easy proof to show that this would also work if angle side angle does. So, if two angles and the non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So in this case, angle A and angle D are congruent, angle B and angle E are congruent, and segment BC and segment EF are congruent, which causes these two triangles again to be congruent because of angle side congruence theorem. So, now that we have a whole bunch of different ways to say triangles are congruent, I give you 4 examples. How do we know any of these triangles are congruent? State how you know, or explain how you know. And if it's not possible, state it. Do your best now. Alright, for the first one, I look at the order. Angle, side, angle. Angle, side, angle. They match up. These two triangles have to be congruent. The way I would say it is I'd go triangle ABC is congruent to triangle DEF. Again, just making sure I have the correct order here. Alright, so where I think I left off was this. Those two triangles in number 1 are congruent. Angle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. In number 2, if I look again, if I just look at the order, yeah, it's a right angle here, but all right angles are congruent. So side, angle, side, side, angle, side. Yep, those two triangles have to be congruent. Reason is side, angle, side. For the next one, I look. I have angle, angle, side, angle, angle, side. Does it work? Well, it's actually no. Remember, it has to be corresponding. So if I would read this around clockwise, angle, angle, side, well, that's 1 mark, 2 mark, side. If I go from 1 mark, 2 mark, I don't have this side right here. It does not work. Yes, it is angle, angle, side, but it fails. It's not in the corresponding location. So I can't say those two triangles are congruent. They still could be, but I can't say they are. 4 here. Again, I have angle, angle, side, angle, angle, side. Well, I look carefully. The markings don't match up again. 1, 2, 1. 2, 1, 1. The marks don't match up. Even though it is angle, angle, side, it's not the corresponding location. Both of these end up failing. What I would have needed instead was segment AC and segment DE to be congruent. If I would have got those two to be congruent, I could then say the triangles are congruent. But because I don't have it that way, not congruent. So, I'm giving you 3 pieces of information. Are the triangles congruent? Explain how you know. Go ahead and try it. Alright, if I know that angle A and angle D are congruent, and I know segment AC and segment DF are congruent, and I know angle B and angle E are congruent, well, do I have 2 angles on a side? It's very possible it's congruent. In fact, if I have 2 angles on a side, as long as they're in the right location, always congruent. Nothing to worry about there. So let me just make sure. Angle B, A, segment AC. So it's angle, angle, side. Going in the same order. Angle E, angle D, and segment DF. It does match up. It is the correct order. These two are congruent. Triangle ABC is congruent to triangle DEF by angle, angle, side. Alright, how about angle C, angle F, segment AC, segment DF, and angle B and angle E? Well, if I look again, I have angle E and F and segment DF, so angle, angle, side. I have angle B and angle C and segment AC, angle, angle, side. Yep, 1 and 2 are congruent, both for the same reason, because angle, angle, side. Number 3 here, angle A and angle D are congruent. So this angle here and this angle here. Segment AC and segment DF. So it's the same one, this right one. Segment AC, segment DF. And then angle C and angle F. Well, again, 2 angles, very likely they're congruent. I have angle, side, angle. Angle, side, angle. Yep, these 2 triangles are congruent. Reason, angle, side, angle. The next one, segment AB and segment EF. Hold on a second. Segment AB and segment EF. It doesn't look right, but let's keep going. Segment AC and segment DF. And then I have angle B and angle E. So if I look at the order on the top one, I would have had side AC, side AB, and this angle. Side, side, angle. I already know I don't have to go any further because if I would have said it the other way, angle, side, side, I know I'm not going to put on there because of angle, side, side, abbreviated congruence postulate. Not going to happen. It doesn't work. So 4, the triangles are not congruent because its side, side, angle does not have a congruence theorem or postulate. And the last one, angle A, angle D, angle C, angle F, angle B, angle E. I'm only given angles. And here's the thing. If I'm only given angles, they could be congruent triangles. However, I have no clue. I need at least one side to match up to its corresponding side. If I don't have that, there's absolutely no way I can say those triangles are congruent. In fact, I can show this quite simply by doing this. This top triangle and this big triangle all have their 3 angles match up, but one is definitely bigger than the other. This does not work because it could be larger, it could be smaller. So 4 and 5 both don't work. 1, 2, 3 all work. 1 and 2 work because of angle, angle, side. 3 works because of angle, side, angle. 4 fails because there's no side, side, angle. And similarly with 5, there's no angle, angle, angle. There are 5 ways to show triangles are congruent, and those 5 are side, 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 hypotenuse, leg, angle, side, angle, and angle, angle, side. You could also say the last one there is side, angle, angle. So if I have 3 sides, matching 3 sides, automatically congruent. If I have 2 sides and an angle matching to 2 corresponding sides and corresponding angle, it depends on which one it is. If it has the angle in the middle, guaranteed to be congruent. If the angle's not included, then it better be a right angle. If it's not a right angle, it fails. If I have 2 angles and a side and they match up correspondingly to the other triangle, automatically congruent, either angle, side, angle, or angle, angle, side. The 2 that don't work is this one, side, side, angle, and angle, angle, angle. Last example, what if I asked you to prove 2 triangles are congruent? Well, if I look at a problem like this, it's kind of complicated. I'm told that segment FE and segment DE are congruent. And I'm told that angle A and angle C are congruent. And I'm trying to look at triangle ADE and triangle CFE. My first step would be to redraw the 2 triangles I'm interested in and mark what is known. So now that I look at this, I see these 2 are congruent, these 2 are congruent. Well, I have one angle, one side. If I get any other corresponding angle match up to any other corresponding angle, I have it. So, first of all, let's put down both givens. I have a side, I have an angle. Well, can I get angle D to be congruent to angle F? There's nothing that I know. Hold on a second, right here. If I look, angle E is actually the same exact angle for this triangle and for the other triangle. So angle E is the same. Why don't I say angle E is congruent to angle E and say reflexive property? So now if I look, I have angle, angle, side, and I have angle, angle, side. I can now say those 2 triangles are congruent by angle, angle, side congruence postulate. It was made a whole lot easier by redrawing the triangles. And honestly, the only thing that I wasn't given was that angle E was congruent to angle E. And once I had that, I had angle, angle, side. Angle, angle, side. And there we go. At this point, you should now know the 5 ways to show triangles are congruent, the 5 shortcuts. You should know which 2 will not work for you. And you should be able to do a few types of flow proofs. Till next time.